Hi everybody, in lesson 12 we're going to develop our last quadratic equation solving technique called the quadratic formula. So we already have the zero product property in factoring, we have completing the square and inverse operations, and today we're going to come up with one final technique that comes from completing the square, and it's called the quadratic formula. I hope your singing voices are ready because you finally get to hear me sing. I wish we could do this in class together, so you have to promise me you're going to sing along at home. So in this opening exercise, let's solve this quadratic equation by completing the square. So when we complete the square, remember we have to have plain old x squared. So I have to factor out a 7 here, and this is already a disaster. I have to factor out a 7, so that's 12 sevens. Oh, goodness. Now I need to make a box. X squared. Cut that in half. Well, half of 12 is 6. This is awful. This is absolutely an awful way to solve. I don't want to keep doing this. Now I need to multiply fractions, but I never listened in 6th and 7th grade, so I'm not really sure what negative 6 sevenths times negative 6 sevenths is. So it looks like the magic number is 36 over... This is ridiculous. This is ridiculous. This is terrible. Could we do it? Sure, we could do this. We could keep going. But at this point, we're gonna just say no. We're gonna say no. There's gotta be an easier way to solve this quadratic equation than dealing with all of this nonsense. So let's put a pause on solving this right now, and we'll come back to it towards the end of the lesson, or I think it's in the homework, one of those two. So we're going to come up with a formula that just spits out the answers. So before we get to the quadratic formula where we solve quadratic equations, let's come up with a linear equation formula, just so you see what I'm talking about here. So solve the general form of the equation px plus q equals 0. So p times x plus q equals 0. I want to solve that for x. So this is something like 2x plus 3 equals 0. It's something just like a nice two-step equation from 7th grade. So let's subtract q. Px equals negative q, and then divide by p. So we came up with a little formula here. Negative q over p. If I want to solve an equation with this structure here, all I have to do is plug in q and plug in p. That's my answer. So I know you can solve both of these in 30 seconds, but I want to show you how we're going to plug into this formula. So px plus q equals 0. So in this equation, p equals 2 and q equals negative 3. So when I plug those numbers in, it's going to spit out the answer. We came up with a formula that just spits out the answer. X equals negative q. Well, what's negative 3? That's what I have there. That's really positive 3. So it's the opposite of q over p. 3 halves is the answer. In this next one here, p equals 7, q equals 11. So my answer is the opposite of q, negative q, over p. It's silly to do this for linear equations because we can solve those easily. But when we get to quadratic equations, we're going to plug in these numbers, a, b, and c, into a formula, and it's going to spit out the solutions. You don't need a factor. You don't need to complete the square. You just need to plug in 3 numbers into a formula, and it spits out the answer. So at this point in the lesson, if you don't want to watch this, that is fine. You can skip ahead until I draw a big box around the formula. The formula is a lot more complicated than the one we just did there. So the formula doesn't fall from the sky. It comes from completing the square. So we complete the square once. We do that awful process that we did above once, and then we're going to use the formula. You don't need to know how to do this. I will never ask you how to do this. I want to show you that it just comes from completing the square. So if you just want to watch, or if you want to fast forward because you say I'm done with you, Mr. Hines, that's fine with me, but I am going to prove the quadratic formula for you right now, and we're going to derive it together. So I want to solve this quadratic equation. I need to complete the square. But there's that a in front of x squared, so I have to factor that out. I have to factor out that a. Why did I put b over a? That makes b when I distribute back in there. And then I need to draw my square, x squared, and then I'm going to take this middleman and cut it in half. I need half of that, b over 2a. So x times x plus b over 2a plus b over 2a. So hopefully you're following along, realizing I'm just completing the square. The algebra might be a little complicated, but all I'm doing is completing the square. So now I need to find the magic number that I need to add. The magic number is b times b squared over 2a times 2a is 4a squared. That's the magic number that completes the square. So coming back over here, x squared plus b over ax plus b squared over 4a squared. But now I need to counteract that. Remember, when we complete the square, you need to counteract. So that's what I added, but remember there's that little distribution step. So you really need to subtract away b squared over 4a. Trust me, that's how that works out. That's how that works out there. Plus c equals 0. Okay, we'll complete the square. What does this trinomial become? Even if you have no idea what I just did, you can tell me this trinomial is the sides of the box. This trinomial is x plus b over 2a squared. And I'm going to, I'll leave them for now. Equals 0. So now we have to do inverse operations. We have to do inverse operations to get x by itself. Because here's x. I need to get rid of all this other nonsense around it. So the first thing I'm going to do is move those guys over. I'm going to move those guys over by doing the opposite. So I get b squared over 4a minus c. That became positive. That c became negative. And just for cleaning this up, I'm going to make this have a common denominator. I just made an equivalent ratio there. I made an equivalent fraction by making a common denominator. So that gives me a parentheses x plus b over 2a squared equals b squared minus 4ac all over 4a. I'm going to divide by a, which actually just sticks another a in the denominator. I know the algebra here gets a little rough, but I want to show you that I'm really just doing inverse operations. Over 4a squared is what that becomes. Now you can all tell me this. How do I undo squaring? I undo squaring by taking the square root. So I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over, I can take the square root of that. What times itself is 4a squared? 2a. And then the final step is to move that term over. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since those have the same denominator, that leads us to our quadratic formula. I can just smush those fractions together. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That right there is my quadratic formula. So hopefully I didn't scare you there. You never have to do that. I promise you, you never have to do that. But here's our quadratic formula. So any quadratic equation, ax squared plus bx plus c, if you tell me what a is, what b is, what c is, tell me what numbers, there's no letters, just there's no x's, it's a equals 1, b equals 7. All we have to do now is plug those into this lovely formula, and it spits out the answers. So the quadratic formula, x equals, I hope you're all warmed up, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll do it one more time, and I'm expecting you to be singing along at home. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Maybe we can do an extra credit assignment where you guys can send me you singing that. I think that's a great idea, and then I'll make a little video compilation of all you guys singing it together. And we can pretend like we're in class singing it. So when we solve any quadratic equation, first thing is it has to be equal to 0. Just like if we were factoring, it has to equal 0. And then you need to tell me what those three numbers are, and then we play everyone's favorite game, plug it in. We plug in to this formula, and it spits out the answers. So let's try it. Let's try it here. Solve each of these quadratic equations by using the quadratic formula. So first thing, is it equal to 0? Yes, it is. It's equal to 0. So now I need those coefficients. Give me an A, give me a B, give me a C. So what A is in front of x squared? What number is there? 1. B is in front of x. The negative comes with it. C is the constant term, -8. So now that I have those three numbers, I just need to plug them into the quadratic formula. I just need to take those numbers now and plug them in to the quadratic formula. So here we go. X equals -b. Well, b's already negative, so two negatives make a positive. It's the opposite of b. X equals -b plus or minus the square root. You need to use parentheses right there. B squared minus 4ac all over 2a. Now we just need to clean this up. Those are my two answers. It's not in simplest form, but now I need to clean these up. So here's what we're going to do. We're going to type what I just highlighted there, not the square root, just what's under the square root into a calculator. And it's important, just had to grab my calculator. It's important that you use parentheses when you square that term there. -3 squared minus 4 times 1 times -8 is 41. So x equals 3 plus or minus the square root of 41 all over 2. That's it. That's all we really have to do. We have a couple things that could happen now. We could check the square root to see if I can tear it apart. 41 cannot be torn apart. Sometimes I like to divide this fraction like this and write my answer as x equals 3/2 plus or minus radical 41 over 2. Sometimes I like splitting my answer up like that. Sometimes I leave it as one combined fraction. But that's the awesome part of the quadratic formula. You take the numbers. I did the crazy completing the square up above. You take the numbers and you plug them in. Let's slide over here. First problem, it's not equal to 0. So let's make it equal to 0. Y squared minus 2y minus 12 is 0. Now we need to pick off those three numbers, those coefficients, so that we can plug them into the formula. Give me an A, give me a B, give me a C. 1 x squared, or y squared, minus 2, and then -12. Those are my three coefficients from ax squared plus bx plus c equals 0. And now we plug it into the quadratic formula, which is right up there. But hopefully you sang it a couple times that it's ingrained in your head forever. X equals the opposite of b plus or minus the square root of b squared minus 4 times 1 times -12 all over 2a. Type what's under the radical into your calculator. X equals 2 plus or minus the square root of something all over 2. Well, let's type this in. -2 squared minus 4 times 1 times -12. I got 52. So now we're basically done, but I have to check the square root here. Can I tear apart the square root of 52? What perfect squares, 1, 4, 9, 16, 25, 36, 49. Do any of these perfect squares divide into 52? 4 does. Radical 4 and radical 13. So it's really 2 radical 13. So what I'm going to do now is split up this fraction. I'm going to split up this fraction. 2 over 2 plus or minus the square root of 52 over 2. It's not x equals, it's y equals in this case. Y equals Why is it y equals? That's what the letter was. So my final answer is y equals 1 plus or minus the square root of 13. Those are my two irrational solutions. So the quadratic formula is easy up until this step, and the hard part is to figuring out where do I go from here. Do I type it into my calculator and get a decimal? What do I do? Do I tear apart the radical? Can I tear it apart? Do I split it apart? Getting to this step here is the important part, though, and after that we can practice what happens. All right, this is not equal to 0, so let's make it equal to 0. I'm going to add 8x and subtract 7. So 2x squared plus 8x minus 7 equals 0. It has to be equal to 0. Give me an A. 2. Give me a B. 8. Give me a C. -7. Thanks, guys. Thanks for the help. I know you were definitely saying those with me. So here we go. Here we go. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Or if you're lazy, you can just write 4 because 2 times 2 is 4. All right, I plugged it into the formula. Now I type in what's under the radical. I forgot my parentheses there. Not that it matters in this case, but I'll be consistent. 8 squared. 8 squared minus 4 times 2 times -7 is 120. -8 plus or minus radical 120 all over 4. Those are my solutions. Well, let's look at this radical 120 now and see what we can do. Using those perfect squares, how can I divide up 120? I actually think it's 4 and 30. So 2 radical 30. So let's divide it now. Let's divide it. -8 fourths plus or minus 2 radical 30 fourths. So that gives me -2. And then 2 fourths is 1/2 radical 30. Those are my two solutions. So again, plugging into the formula is not hard. It's the cleanup after that that makes it a little bit difficult. I think we got one more and this lesson's done. Awesome. The entire next lesson is going to be practicing the quadratic formula, by the way. So this is the focus of this lesson and the next lesson. Well, it's equal to 0. So give me an A, 3. Give me a B, -4. Give me a C, -4. I pick those numbers off from the equation. It's not fun without having you guys in class to yell these at me, but that's okay. We can do it from home still. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times 3, which is 6. I like to do that little 2a part in my head, right? All over 2a. 2 times 3 is 6. All right, and then we type this guy into our calculator here. -4 squared minus 4 times 3 times -4 is 64. Wait a minute. I really like this problem. I know what the square root of 64 is. What times itself makes 64? This entire thing here is really the number 8. The square root goes away, everything goes away, because it's really 4 plus or minus 8 over 6. Well, wait, I can do that. 4 plus 8 divided by 6. 12 divided by 6 is 2. 2 is an answer. Or I could have done 4 minus 8 over 6. I could have done -4 6, which is -2/3, is my answer. So what this tells me is I have rational number answers. I got rational number answers. That means I actually could have factored this. I actually could have factored this. When we get those irrational answers, that means we can't factor. But in this case, I actually could have factored this trinomial here. But the quadratic formula always works. That's the beautiful thing. Completing the square always works, but it's not pretty. The quadratic formula is methodical, and it's just the same steps every single time. I'll see you in the next video when we practice solving with the quadratic formula.